Hey Andre, so this is the final sprint. First thing I'm going to do is walk through basically the creation of a demo object, and through this demo object I'm going to show off the various subsystems. So first thing I'm going to do is briefly walk through the drawable and updatable. So when a user creates a class, whatever it is, they're obviously going to inherit from GameObject, and then I have this thing called a world component, and I'll talk about that a little later where it's applicable. Um, so Obviously, I kind of expect the user to have a graphics object, um, so I don't provide that for them. That's in the documentation though that explains that they need one of those. So, um, all these functions, these are the virtual methods that come from game object. Those actually should all be override just to show that they work, but um, I'll do that before I'll clean that up. Um, So first things first, you go in the demo object constructor. All I have right now is I'm just newing up a graphics object. So the first thing you do if you want to register an update function on a drawable, we'll do drawable first. Make that call, and then in the draw function, call its render. Okay, so the second thing you need is the scale, position, rotation to create a world object, world matrix for the graphics object. So these variables, scale, position, rotation, and world matrix, are all part of the world component class. I can show that off, but it's literally just something to hold those variables. It also holds translation speed and change in rotational angle. I was considering putting that part of game object, but I decided against it in case you wanted some kind of game object that um, I don't know, theoretically didn't need to have scale, position, rotation. I'll probably ask about this in class just to make sure I'm doing it right, but um, I don't mind how it's set up. So with that, I'm gonna go ahead and build it. So hit F5 here. And boom, we have a ship position. Right now, nothing's been updating, so all it's working is the drawable right now. So next we'll work on the update function, and that is a simple call, register updatable. And then if I go to the update, this is where the user would do their work. So right now we'll just have a print standard. Go ahead and build it again. Pull up the console, and you can see the updates working. As far as deregistration goes, right now, on cleanup, everything behind the scenes, the respective managers clean up for themselves. So technically the user doesn't have to explicitly call a deregister function. I have it in my documentation to recommend putting a deregister function in the constructor, or destructor, in case the object is deleted during their scene. So right now I'll go across the basic data flow of these two subsystems. They're virtually identical, so I'll only walk through drawable. So I go through register drawable, I get a private scene manager. I have a private scene manager so the user does not have access to it, they just have an interface through clusters called regular scene manager. hit currency, let it register the drawable. So that's that. I'll go through all the deletion in kind of like one fell swoop, so I won't cover that right now. But next I kind of want to go through the input system. But before I do that, actually I want to talk about, I should have done this first, in the Blu-ray content function. This is where the player does all their doing. So this demo object, this is inside the load game content function. So this is where the user would create all their objects. So now into the inputable subsystem. So for the inputable subsystem, all that's required is typing in a register inputable function, specifying the key you want, and then the key press event, either press or release, and then the user in the overloaded key pressed function would do something like this. And then the update is important to update the world matrix based on these new values you get from the key press event, and then set the world matrix again to the graphics object, so it actually moves. So we can test that out. And we have shit moving around, so that's all along good. Now I'm going to get into code specifics on what's lying underneath the hood. So we'll go through a full register event. So doing this really quickly, I just want to show you the flow of the data. We're going to the registrable inputable function. This is a rather long call, so I'm going to continue onward to the actual input manager register function. It checks the active key count, and if it's 0, that means that that key object isn't in the input manager, so it's going to go ahead and create a new one, which it does. The key object register, again, this is kind of like another sub manager in itself, so it makes sure that that specific key press event with that inputable isn't already in the list, and it's not, so it pushes it to the front. And that's basic registration. So the next thing I want to discuss is the alarmable component. All the user needs to do is type in the function register alarmable with the ID and the time, and then they need to fill out the corresponding callback. So here I'm just using print statements. Fire it up. Shoot, it's debugs. Alarm 4 is going off. It was set for 2 seconds. So you notice that alarm 4 is constantly going off. This occurs because the user is not deregistering the alarmable in the callback. So this is in the documentation as well. To recommend to always deregister their alarmable after that callback. I wasn't sure if I wanted to have that function be kind of the default behavior within the underlying alarmable class, or even if there's a way to do that, since it's a virtual function, to get that deregistration to happen automatically. I suppose I could fiddle with the alarmable class, but kind of made more sense to me to leave it up to the user in case for some reason that they wanted the alarmable to keep going off for debugging purposes or something. So now that that function is there, those are in there, we'll run it again. Alarm 4 went off, alarm 0 went off, and alarm 1 went off, and that's all the alarms. So going into the collidable component, the only thing that the user needs to do is register collidable and overload that function. This is the call that the user needs to make. It's also explained in the documentation that you have to include the collidable group .h. Also, they have to overload the do-register collidable, and it's also recommended again to make sure to deregister that collidable in the object destructor. After that, the collidable needs the model object. That's how the bounding sphere is calculated. And again, this is all explained in the documentation. So they would need a set model call from the graphics object, and then they would need to set world matrix, which just takes in a pointer, or excuse me, the world matrix. And this call right here is one of the arguments for having the world component just smashed in together with the game and the game object, or even maybe inside the collidable class because it needs that world matrix. I wasn't sure what the best way to separate everything out would be, but that's how it is so far. In addition, my collidable class has a function called draw debug sphere, and also a variable that return is true if the object is colliding with something. So if the user wants to, they can draw that debug sphere, and it takes in just 3 floats to describe the color of the debug sphere, so it allows for easy debugging. The next thing the user will need to do is to go back into the load game content function and set the collision pair via the scene manager, and that call looks like that. And after that, the user should be good to go, so I'll fire her up. The last steps in setting up collidable is to overload a collision function of the object you want it to collide with. In this case, we're going to collide with the cottage object, so the user would need to input this function and define it within their class. And then we should be good to go. Actually, sorry, we're not good to go. We needed to define the collision between the cottage object, so now everything should be working. Okay, so we're going to back up the spaceship and the cottage. Now you can see they're colliding. No, they're not. And if the user wants to, they can set that enemy hit equals true function. And because in the draw method, I have this draw debug sphere, the debug sphere should change color. It is. That's pretty much it for the collision system on the user end. So the next subsystem I'm going to tackle is the terminable. I'm actually going to end this video here because I'm almost out of recording time. I'll start it up in part 2.